Good day, gentlemen. As the pipeline networks are aging, we are needed to address even more challenges towards the integrity management of this valuable asset. Cracks are considered to be a critical defect and by several standards is predicted to fail under normal process conditions and operating pressure. Such critical defects can adversely affect the integrity of a steel pipe and requires immediate attention in order to avoid a failure. My name is Noman Anwar. I have been working in oil and gas industry since last 20 years and I have been fortunate enough to be closely knitted with EMAT technology since its early development stage, validating the technology with major clients as well as through to commercial implementation and also in the enhancement as we go. Here I would like to take you through my brief presentation regarding EMAT services. First and foremost, why would a customer need EMAT inspection and how a service provider can position itself in this market globally. Now let us look at the challenge. The term cracking refers to formation or existence of crack primarily in its propagation stage. Cracking can be due to various root causes in pipeline metals. It is usually found to be a result of several parameters, including the microstructure of the metal and the presence of stresses. These effects can be exaggerated by the presence of hydrogen, a corrosive environment, cycling of stresses, and defects introduced through fabrication processes. The main types of cracking found on pipeline systems are due to fatigue cracking, high pH stress corrosion cracking, near neutral stress corrosion cracking, hydrogen induced cracking, HIC as we call, and corrosion fatigue. Now typically ultrasonic crack detection tool, which we call UTCD, can be utilized to inspect cracks in a oil pipeline or a liquid pipeline. However, due to its own technology limitation, that is for an ultrasonic probe to transmit and receive an ultrasonic wave, it needs to have a liquid couplant in order to transfer the ultrasonic wave, thereby limiting the ultrasonic technology to be utilized within gas pipelines, or making it really complicated in some cases where liquid batching has been attempted. This is the colony of SCC, a colony of cracks, which can be typically found by a crack detection tool. This is a bathtub model, a life cycle of a typical SCC growth in a pipeline. The first stage is the longest of all. It is initiation, often considered the longest of all the other three stages here in a pipeline. Very difficult to predict where cracks will initiate in a pipeline. The second stage is propagation. Now, techniques to mitigate the cracking threat tend to focus during this stage. Realistically, according to CEPA recommended practices, SCC at a transition stage 2 and 3 is targeted by inline inspection crack detection technologies. Individual cracks already initiated by exceeding detection threshold is identified before the mechanical growth becomes increasingly important, because if not identified, it may lead to failure at the end of the SCC's growth life cycle, which is the third. The failure stage is relatively short, and a final stage where the remaining wall thickness of the pipe is insufficient to support the internal stresses. Now, to overcome this problem, NDT researchers have been working through many years on advanced ultrasound and shear wave techniques, and hence the EMAT technology has evolved and has been validated to be a significant NDT method for inline inspections. EMAT is a shear wave technology that can be used in both oil as well as gas medium. And most importantly, for moderately clean pipeline as compared to any ultrasonic tool that would need a pipeline's internal surface to be clean as mirror. In order to be clean as mirror, in order to eliminate the noise within the signals that has been obtained during the inspection run. Unlike ultrasonic shear wave, which transmit ultrasonic waves at a set angle of 45 degrees and receives the echo from the from any crack-like defects, any crack-like or any flaws within the pipe surface, the echo signal that is obtained from an ultrasonic shear wave. Now, unlike ultrasonic, the EMAT generates the shear wave within the pipe wall, and due to this property, it generates both the transmission as well as an echo signal. When it comes to ILI techniques for crack detection, as I said, unlike ultrasonics, EMAT can withstand moderately clean pipeline. Cracks considered to be a critical defect, and as we know by several standards, is predicted to fail under normal operating pressure and process conditions. Such critical defects can adversely affect the integrity of steel and requires immediate attention. And to avoid the failure, the vast majority of pipeline integrity systems are based on threats associated mainly with associated with mainly corrosion defects. Over the recent years, cracks in line inspection technologies such as EMAT have been a significant step forward and is being utilized more and more often than before. This is to ensure the integrity of pipeline network fully covered. So it is of course a proactive inspection, and we go with the exploratory excavations, and hence the EMAT is proven a tool for greater management than finding SCC near to the failure. Now let us look into the EMAT measurement principle. The physical principle of EMAT is to produce a guided wave through the combination of Lorentz force and magnetostriction. To generate the EMAT wave, a coil is placed with a magnetic field. To generate the wave, a coil is placed within a magnetic field, and a current pulse is sent through the coil. Echo signals are produced within the pipe wall, and gain is calculated from transmission signals, thereby detecting the flaws within a pipe wall based on the consistency of echo signal, and as a product of gain is measured within the transmission signal so as to determine the adhesion of coating. This absolutely is the frequency of hum produced within the ultrasound shear wave generated by magnetostriction and Lorentz force. This is the hum we hear that's happening within the pipe wall. The pipeline defects such as cracks. The phenomena of cracking in pipelines can be due to various factors, and most of the found cracks are due to stress corrosion cracking, can be long sink defects such as lack of fusion or whatever. It could be due to the axial gouging, it could be due to the fatigue, etc. etc. Typically, ultrasonic crack detection tool can be utilized to inspect the cracks in a oil pipeline. However, due to its own technology limitation, that is for a UT pure probe to transmit and receive an ultrasonic wave, which needs a liquid couplet, thereby limiting the technology to be utilized in gas pipelines, or making it really complicated, as I said. And unlike ultrasonic, EMAT can withstand moderately clean pipeline, as well as it can run in all the mediums, liquid, gas, as well as the multi-phase. To overcome this problem, NDT researchers, of course, have been working for many years, and this technology has enhanced and advanced ultrasonics, and hence the EMAT technology has evolved and validated for NDT inline inspections. EMAT, of course, is a shear wave technology that can be used in as I mentioned, in all petrochemical products. And from service providers' point of view, I would like to suggest that they help the pipeline operators in finding the high consequence areas, or the areas that are most susceptible for cracking, and identify them utilizing their internal integrity tools and databases, so that a EMAT tool can be prescribed or recommended to the EMAT candidate pipeline, and hence this suggestion and can be forwarded to the concern of pipeline operator. Thank you. I really appreciate your time, and I'm looking forward. If you have got any questions, please write to me or call me, and I'll be very glad to answer your questions. Thank you very much for your time, and I look forward to your feedback. Thank you very much.